Good morning, good afternoon, whatever the case may be to whoever is watching this. Just wanted to welcome you to my presentation on my report, The Physiological Responses and Fatigue Associated with Playing Role of Offence and Defence in Amateur Basketball Game, a randomised experimental crossover study. Basketball itself basically has been around for decades. Everybody knows it and it's enjoyed by all ages of all genders all around the world. And it obviously is an Olympic event. The game was formulated by a Canadian in 1981. Research within the physical, physiological, morphological and activity responses has increased over the years. Several studies have been done. One, our own Aaron, has conducted 2 different reports on that, one on males, one on females. And previous measures have been limited, however, to heart rate, blood lactate concentration within training, gameplay, competition and competition conditions. Basketball predominantly relates to the anaerobic energy system. However, from different types of studies done, it also is now evident that aerobic energy system is also used. Anaerobic glycolysis is the production of lactate as a byproduct and occurs when high intense exercise persists from 10 to 30 seconds and the energy has been derived from the muscle oxygen stores, which we all know from Human Body Systems 1 and 2. Purpose of the study is to describe and compare the physiological demands and fatigue responses of offence and defence playing roles during a basketball game. Our null was the roles of offence and defence during basketball gameplay has no difference in blood lactate and fatigue levels, therefore the alternative being that the role of defence during basketball gameplay has a higher blood lactate and fatigue levels. From our sample group, 14 sport and exercise students from residential school at CQU were participants within this study. Results from a demographic point of view showed that there was 5 females, 9 males, average age of 25, average height 177 centimetres, average mass 78 kilos, average years in training is 9.84 years and average percentage body fat was 18.02. 2 independent variables, which was offence and defence. Dependent variables were our heart rate, absolute relative max peak, absolute relative heart rate in total time, which was taken over the basketball game, absolute and relative heart rate during the playing time itself, not the sub time, blood lactate levels, the sprint line drill times and fatigue. Measures of the mean standard deviation were used to collect this data, obviously from demographic independent and dependent variables. A paired t-test was conducted comparing the 2 response samples. Alpha level of 0.05 was used. Type 1 and Type 2 errors were also revised to prove whether the null was correct or not. Equipment used, the basketball stadium, basketball heart rate monitors, timing gates, handheld lactate analyzer, all blood work details, and then skin calipers. Methods, so basically we all warmed up, blood samples were taken, we then had to perform a line drill test, which was 143 metres, which is the length of the basketball court. We then from there had to recover for 10 minutes. We then got divided up into offence and defence for a 4-on-4 half-court game scenario. We then subbed off in between with a random individual roaming to make up the slack. We then, after the blood samples were taken, we went back on, and then at the end of it, another line drill test was taken, and again, blood take levels were measured in that point, which you can see up on my graph. So results. So we've got there the absolute, the relative, absolute, mean, absolute heart rate mean again for game time. So again, those sub times were taken away from that because we weren't measuring when they were being subbed, we were measuring when they were being active. Obviously the biggest thing that I can probably point out in through here is that there was a significance, and that being that the relative heart rate max reading between offence and defence was a significant difference. This is a better chart that actually does show this a little bit better. Obviously offence being in blue, defence being in red, and you can see there that predominantly offence is a lot higher with our heart rate levels at a max level compared to defence, indicating that offence was creating more fatigue in terms of heart rate. This is just another one talking about the averages in general. This, again, there was no significance found within this one. The main one was going back to our results chart with the offence and defence relative heart rate max. Okay, going into our discussion. So basically there was no real significance in heart rate responses found between playing periods in a study for female elite basketball players, which was in a study done by Aaron in 2001. Findings on all heart rate measures expect for relative heart rate max during reading samples taken for offence and defence, which presented with a significant difference in our level for 0.023. So the main comparisons are that as max heart rate, offence was presenting with 90.83% and defence was 85.74%. So there is a big difference between offence and defence with relative heart rate max. We had predicted that defence would present with a higher blood lactate level and fatigue levels. With both of these measures, however, didn't show any significant difference. Same within Aaron's study done in 2011 and also Rodriguez in 2003. It wasn't much of a difference at all. Slightly higher blood lactate levels were done in that study, but again, they were in close range of each other between 90 and 91%. Research done by Capricornio in 2013 presented with a significant difference between 3 sprint tests, which was less than 0.05 again, reporting that the time and ideal time were significantly worse at the end of each match. In our line drill sprint test in this study, it actually showed that in defence, everybody actually improved on average in their time, which would actually come back to the fact of saying that in defence, it wasn't as hard as offence, presenting with that they actually had time to recover, so that when they went back to do the line drill test, they could improve on their time. And I think the average on that was between 25 seconds of improvement, whereas in offence, when they played, it was actually a decrease in time of 45 seconds. So it was actually saying that in defence, they were getting more recovery, so it wasn't as fatiguing as offence. Once again, the study presented similar results from previous studies that have been done. Major differences, I think, between the two was obviously the fact the game style. In a lot of studies, it was using elite players that have been playing for years. Our study was only looking at students ranging playing an odd 4-on-4 game of basketball. Also, a lot of training implications were made on that too. So a lot of the athletes in the other studies had been training for 3 or 4 sessions a week, whereas we were just grabbed together from obviously res school. But a lot of the students, particularly the females in the group, hadn't played basketball before. So that may have been something that may have been a determining factor there. So I guess to wrap everything up, the role of offence and defence in gameplay in amateur basketball within a modified game requires similar psychological needs and creates similar response outcomes relating to fatigue. Practical implications for this: training in both aerobic and anaerobic metabolic systems to improve both offence and defence roles within a team. Rotating offence and defence players within training and gameplay competition may help too, so not one player gets focused on offence or defence, and that way that players can adapt and change between different roles within basketball so they can be utilised across all. Just a list of my references. A big thank you to Aaron for helping him with all the data analysis, and Greg with using the timing gates and any questions and queries I may have had, and also last but not least Patrick. So thank you guys. I hope that was in a nutshell. Again, most of my stuff's up onto the PowerPoint presentation, but thank you and enjoy the film. Okay, thanks guys. Bye.